You're floating, weightless, calm. You could be drifting in a swimming pool with your eyes closed, except for one thing. Ahead of you, the stars are wrong. There's a circle where the universe just isn't. No light, no color, no depth, just absence. And around that absence, the rest of space is bending. Stars that should be behind the void are smeared around its edges like the cosmos is being squeezed through a funhouse lens. You're not accelerating. No engine noise. No G-force. No warning light. You feel exactly like you did 5 minutes ago. 10 minutes ago. An hour ago. That's the thing about falling into a black hole. You don't feel the fall. You feel nothing. And by the time you feel something, you have 12.8 seconds to live. But we should back up. Take our sun, all 2 trillion tons of it. Now, collapse it. Crush it down and down until every last kilogram is packed into a ball 3 kilometers across. That's smaller than most airports. At that density, gravity at the surface becomes so extreme that the speed you'd need to escape exceeds the speed of light. Light goes in, light doesn't come out. You've made a black hole. They're not theoretical, they're everywhere. As of our best estimates, there are about 40 quintillion of them in the observable universe. Almost every galaxy has a supermassive one at its center, including ours. Ours is called Sagittarius A star. It sits 26,000 light years from where you're watching this, weighs 4.3 million times more than the Sun, and in May 2022, the Event Horizon Telescope took its picture. If you dropped it inside our solar system, it would only stretch about a fifth of the weight of Mercury. Tiny. But if mass had a personality, this thing would be a quiet giant who hasn't stood up yet. And it's not even close to the biggest. The largest black hole ever found, Phoenix A, has a mass of 100 billion suns. Its event horizon is 100 times the distance from the Sun to Pluto. At light speed, it takes 71 days to go around it. Yale astrophysicist Priyamvada Natarajan thinks it might be at the theoretical limit, the biggest black hole that can exist, the universe's final boss. We're not falling into that one. We're falling into ours. And we're already close. Here's what's going to bother you. Nothing is happening. You're in free fall toward the most extreme object in the known universe, and you could eat a sandwich. You could do a crossword. Physicist Brian Cox put it this way. We could be approaching this in this room now, and we would have no clue. Einstein figured out why. Free fall is indistinguishable from floating. You're not being pulled. You're following the curvature of space-time itself, the same way a marble rolls along the dip in a trampoline. And if the trampoline is smooth enough, the marble doesn't even notice it's rolling. What you see is another story. The accretion disk, a ring of superheated gas spiraling around the black hole at half the speed of light, heated to 1 billion degrees, is doing something impossible. It's wrapping. Light from behind the black hole is being bent by gravity around it and funneled into your eyes. You're seeing the front and the back of the disk at the same time. Nested rings of light, called photon rings, glow in halos where light has orbited the hole once, twice, 3 times before escaping toward you. In May 2024, NASA astrophysicist Jeremy Schnittman ran this exact scenario through the Discover supercomputer at Goddard Space Flight Center. 10 terabytes of data. 5 days of computation. What a laptop would need a decade to finish. The result was the most accurate simulation ever made of what you'd actually see falling in. And the most unsettling part of that simulation isn't anything visual. It's the silence. Your body doesn't register a single warning. The most dangerous object in the cosmos is swallowing you, and you feel like you're sitting in a lawn chair. Right now, your story splits. There are 2 versions of what happens next, and both are true. In your version, time passes normally. You fall, you cross the event horizon, you die. All of it takes minutes, but someone watching you from far away sees a different movie. They see you slow down. Your image gets redder, dimmer, like a photograph left in the sun. You inch toward the event horizon, and you never, ever cross it. You freeze at the edge and fade to black over an infinite stretch of time. From the outside, nothing ever goes in. That's why astronomers used to call black holes frozen stars. This isn't poetry. It's measured. In 1976, NASA launched an atomic clock into orbit and confirmed gravitational time dilation to Einstein's exact prediction. At sea level, time passes about 1 billionth of a second less per year than at the summit of Mount Everest. Near a black hole, this effect goes to infinity. Your clock stops. Your light gets stretched, what physicists call gravitational redshift. Shifting red, then infrared, then microwave, then radio, then nothing. You become a ghost imprinted on the edge of oblivion. But from your side, you look up and the universe is fast-forwarding. Stars flicker, galaxies wheel. The entire future of the cosmos is playing on a screen above your head while you fall toward a line you've already crossed. And you feel nothing. That's the punchline nobody tells you. The event horizon, the most absolute boundary in the universe, the one-way door that traps light itself, and you cross it like stepping from one room into another. For a supermassive black hole like Sagittarius A star, the tidal forces at the horizon are about 2.2 times 10 to the negative 10 g, 1,000 times weaker than what you feel standing on your bathroom floor. What changes is what you see. The universe above you is shrinking. Light from fewer directions can reach you. The blackness rises from all sides. Everything you've ever known, every star, every galaxy, every person, contracts into a single, shrinking circle of light above your head. A cosmic porthole, closing. Here's how Brian Cox explains the physics. Space is flowing inward like a river. At the event horizon, that river moves at the speed of light. You're a fish swimming against a current exactly as fast as you can swim. You can't make progress. Inside, the current moves faster than light. You're done, unless Einstein was wrong. In 2012, 4 physicists, Almhiri, Marolf, Polchinski, and Sully, proposed the firewall hypothesis. The event horizon isn't smooth at all. It's a searing wall of high-energy particles that incinerates anything on contact. A 2025 paper connected this idea to the Wigner's friend paradox and argued firewalls might be unavoidable. So maybe you don't feel nothing. Maybe the last thing you feel is everything, all at once, as a wall of fire at the edge of space-time turns you to plasma. We don't know which version is real. Nobody's come back to say. You're inside now. And the rules have changed. Turn left, you move toward the center. Turn right, center. Backward, center. Every direction you try to go, all of them, including the ones you haven't thought of, leads to the same place. It's not that something is pulling you. Space-time itself has rearranged so that all roads end at one destination. The singularity. And here's the part that will break your brain. The singularity isn't a place. It's a moment in time. Inside a black hole, the distance to center becomes a time coordinate. The singularity is in your future the way next Tuesday is in your future, and trying to escape it is like trying to run away from tomorrow. You can't run away from tomorrow. The best survival strategy? Do nothing. Float. Any movement, any thrust in any direction only gets you there faster. The longest you can live is by surrendering completely. You can still see the outside universe through that shrinking circle of light. It's still up there, spinning, expanding, moving on without you. You're watching a cosmos that has already forgotten you exist. Now you feel it. The gravity at your feet is stronger than the gravity at your head. Not by a lot, not yet, but it's there. A tugging, a stretch, like being on a rack in a medieval dungeon, except the torturer is a point of infinite density and he's very, very patient. Your feet pull away, your shoulders squeeze inward. You're being extruded, stretched long and compressed thin like toothpaste through a tube. Physicists call this spaghettification. Stephen Hawking named it. Because physicists are, apparently, hungry. It gets worse fast. The tidal force scales with the cube of your distance. Halve your distance, the force multiplies by 8. Connective tissue tears. Bones snap along their length. Your organs separate. Cells pull apart. You become a thin ribbon of biological matter 1,000 miles long. Then, the atoms separate. Protons are ripped apart. The quarks inside them, the most fundamental building blocks of matter, are torn from each other. You are a stream of elementary particles spiraling inward at nearly the speed of light. This isn't speculation. We've watched it happen to stars. When a star wanders too close to a supermassive black hole, the same thing happens on a cosmic scale, a tidal disruption event. Astronomers first spotted them in the 1990s. In 2025, they detected the most energetic one ever, a flare called J2245 plus 3743, 10 billion light-years away, releasing the energy of 10 trillion suns, 30 times more powerful than the previous record. They watched a star get turned into spaghetti. That's you now, except nobody's watching. You're gone. But the question that haunts physics isn't what happened to your body. It's what happened to your information. Every atom in you carried data, a position, a spin, a charge, a history. Quantum mechanics has one ironclad rule: information is never destroyed. It can be scrambled beyond recognition, but it cannot disappear. It's the universe's one unbreakable promise. But you just fell into a place nothing escapes. And in 1975, Stephen Hawking showed that black holes eventually evaporate, slowly leaking energy as faint thermal radiation over timescales, so long they make the age of the universe look like a coffee break. A solar mass black hole takes 10 to the 67th power years to die. The universe is 13.8 billion years old. Do the math. Don't bother. You can't. So when the black hole finally evaporates, where did you go? Where did your information go? This is the black hole information paradox, the biggest open question in physics. For 30 years, nobody could answer it. Then in 2019, a group of physicists, Pennington, Almhary, Engelhardt, Marolf, Maxfield, Maldacena, published a series of papers that changed everything. Using a concept called entanglement islands, they showed that regions inside the black hole become quantumly entangled with the radiation leaking out. The inside and the outside, at some deep level, are the same place. Your information isn't trapped. It's slowly, over eons, encrypted into the radiation the black hole breathes out as it dies. You escape, just not as you. But the story doesn't end there. Some physicists think you never went in at all. The fuzzball model from string theory says black holes have no interior. They're tangled quantum surfaces with no horizon and no singularity. Some think your information gets shunted into baby universes that bud off from ours like soap bubbles. Some think reality itself is a network of entangled quantum bits, and asking where did you go doesn't have a spatial answer because location itself is an approximation. A December 2024 paper proposed that these quantum effects might leave signatures in gravitational waves from merging black holes. And next-generation detectors in the 2030s might actually see them. The first real evidence. The first crack in the door. As of November 2025, at a conference at Stony Brook, 50 years of the black hole information paradox. Physicists still can't agree on the answer. The debate is live. The mystery is open. You are, in some very real sense, still falling. There is a black hole at the center of our galaxy right now. 4 million suns compressed into a space smaller than Mercury's orbit. We took a picture of it. And the more we study it, the more it tells us about the strangest thing of all. Not what's inside the black hole, but what space-time is, what reality is, what information is, what you are. Black holes are where our physics breaks. And that's not a failure. That's an invitation. If it's clear tonight, go outside. Look toward the center of the galaxy. There's a monster there that eats light and bends time. And it might be the key to understanding everything.